Hey Algebra 2, welcome to lesson 92. Today we're going to be talking about boat in the river problems. I used to think when I was younger and in school, like nobody actually taught you these problems. You just went to a test, like a national exam, and there was always one of these problems on the thing, and no one ever taught you how to do it. So I used to think that these are like the hardest things ever, to try to figure out the rate and the time and the distance of a boat going down the river or going up the river or whatever it is doing. But actually these are not hard, okay? You literally only need to learn one more step for rate times time equals distance in order to understand what is going on with the river. Now, again, I'm going to promote my way of the cuadro. If you do the equations in the book, well, estoy dejando de hacer eso because then it's going to become weird when you do the boat in the water, but that is your decision. If you're masochista and you want to do the equation, go for the equation. If you want to learn it my way, well, aquí estoy. Okay, so here we go. Look what it says in example 1. Well, first of all, you do need to look at the equation. Sorry, we do have to refer to the equation just so that you understand that when a boat is going down the river, all of a sudden it becomes different than a car going down the road. Why? Why do you think it's different? Why do you think a boat going down the river is different than a car going down the road? Because the current is also moving in the river. So in the road, the road underneath the car is not moving, okay? So it is just you and the car doing the work, right? But in the river, when you're going downstream, so that means with the corriente, your rate is going to be the boat and the water's rate because they're going to work together to get you down the boat faster. But if you have a boat that's going upstream, so against the current, then all of a sudden you have the boat's rate minus the water's rate because the water's working against you, okay? Which is actually what we're going to be talking about in physics today. It's called drag. So, you do need to understand that when you do the rate of boat in the water, now you're going to have two elements to your rate. If it's going downstream, it's boat plus the water. If it's upstream, it's boat minus the water, okay? And how do you, just think about it. You don't have to really memorize anything. You just have to remember which one helps the boat. Downstream helps the boat because downstream the current is flowing too. So it's going to be two speeds working together, so you have to add them together. Upstream, the water is working against the boat, so it has to be minus, okay, because it's going to be a lesser speed. So it says in 92.1, Robert and Clay could go 60 miles downstream in the same time it took them to go 20 miles upstream. So 60 miles downstream, 20 miles upstream. If the speed of their boat was 8 miles per hour in still water, okay, so that means it's just the boat speed. What was the speed of the current and what was their times? Okay, so we have in still water, that means the boat is 8 plus W, and upstream is 8 minus W, okay? When they say still water, this means like if the boat was not moving, this is how, if the water was not moving, this is how much the boat can move by itself, okay? And we don't know the time, but it did say that they could go, in the same time. So time is equal to time. Okay? So now let's do our equations. This times this is going to be 8t plus tw equals 60. And then the other one is 8t minus tw equals 20. Which is just absolutely beautiful because they already cancel out your tw for you with the negative and positive. And you're left with 16t equals 80, so t equals 5. If t equals 5, then let's just plug it into one of these. So it's going to be 8 times 5 is 40, plus 5w equals 60, right? So then we solve for w, and w equals 4. So that means the rate of the water was 4, and the time is 5. Okay? Here we go. Let's do 92.2. steamboat Juby Fountain could go 70 miles downstream, so downstream, upstream, 70 miles downstream in 5 hours, but required 6 hours to go 48 miles upstream. What was the speed of the boat in still water, and what was the speed of the current? Okay, so they didn't give us anything here, so we were left with B and W are unknowns. Oops, fair on, B minus W over here for upstream. Okay, so let's make our equations. That's going to be 5B plus 5W equals 70. And then 6B minus 6W equals 48. So I'm going to make, multiply that one by 6 and this one by 5, so I can cancel out my W's, right? So I have 30B plus 30W equals 420. And then 30B minus 30W equals, I still can't find my calculator. 48 times 5 is going to be 240. So we cancel out our W's and we're left with 60B equals 660, right? So B equals 11. No, wait. Right, 11, yeah. Let's make sure we're right. And then, so B equals 11, let's just plug it into here. It's going to be 55 plus 5W equals 70. So that's W equals 3. There you go. Okay, and let's do one more, example 3. The water in Flint River flows at 5 kilometers per hour, so that's the water's rate. A speedboat can go 15 kilometers upstream. In the same time that it takes 25 kilometers downstream. Same time, so the times are equal. How fast can the boat go in still water? So we know that it's B plus 5 over here and B minus 5 over here, and they're looking for B. Okay? So let's go ahead and make our equations. Here we go. BT plus 5T equals 25. And then BT minus 5T equals 15. It's going to be an interesting one. So that's going to be 2BT equals 40. So BT equals 20. What's BT? Absolutely nothing at this point, right? So, I'm not trusting this one that we're going to end up with B as our, oh yeah, okay. Here we go. So then we have, okay, let's plug in BT over here to get 20 plus 5T equals 25. So we can find T. So that's going to be, okay, T equals 1, right? So let's go back to the equation again. So that's B plus 5 equals 25, because now we plug in the T for the 1. So that means our B is 20. Whew, I had my dudas, but that was the one. Okay, so those are 3 examples of how those problems can go. Now go ahead and do your practice and see if you understand how we get the answers. Okay guys, here are your answers. For A is T equals 10, W equals 1. For B is B equals 7, W equals 4. So how do we get this one? It says that Annie and Patrice could go 50 miles downstream in the same time, so the time are equal, that it takes them to go 30 miles upstream. The speed of the boat, so B is 4. So you have 4 plus W and 4 minus W. We go 4t, WT equals 50, 4t minus WT equals 30. Cancel out your WT, and you're left with 8t equals 80, so t equals 10. Plug t back into this equation and get W equals 1. Over here, it says that they could go 33 miles downstream in 3 hours, but 4 hours it took to go 12 miles upstream. They want to know the speed of the boat, and they want to know the speed of the current, so they want to know B and W. So B plus W for downstream, B minus W for upstream. So it's 3B plus 3W equals equals 33, and 4B minus 4W equals 12. So then you're going to need to do elimination, but you have to multiply this by 4, this by 3 to cancel out your W's. You get 24B equals 168, so that's B equals 7. Plug B back into here and solve for W, which is 4. Okay, if you guys have any questions, let me know. Bye.